So this is the video for the first lesson in chapter 5, which you should be doing on Friday, October 16th after the test. Okay, so this is our worksheet for today, 5.1a or 5.1 day 1. How good is Mrs. Gallus at free throws? So it asks you to use an applet that I'm just going to use here, and we'll, instead of each group doing their own version of the applet, I'm just going to do one up here and then we'll kind of all use that. Okay, so here's the basic idea. Mrs. Gallus, who is the teacher who made this worksheet, says that she has an 80% free throw rate. So as in, on average, she makes 80% of the free throws that she attempts. So we are going to test out that claim that she makes with some probability here. So this app is going to represent her actual shooting. So the little picture down below has the basketball and the hoop. It's actually going to either go in or not every time I tell it to shoot, and it will keep track of the percentage of hits and the percentage of misses. So for example, if I press shoot, the first shot missed. And so under hits there, it says she has got 0 hits out of 1 try. So she has a 0% hit rate right now. Or misses, she got 1 miss out of 1 try. So she has a 100% miss rate right now. So on this graph, you can't see it, but there is in theory a little dot on the 0 there. Okay, let's do another shoot and it'll make more sense. Okay, so she tried and missed again. So she still has a 0% hit rate, still has a 100% miss rate. So keep in mind that this graph on the right is graphing percent of hits, percent of makes when she makes the basket. Okay, let's do another basket or another shoot, another shot. She missed again. Oh boy, she's having bad luck. So she's still at 0%. Let's do one more. Oh, she finally made one. So now her hit rate is 1 out of 4, or 25%. Out of the 4 possible shots, she made one of them. That's 25% of the time. So notice that our graph went up to 25. And I am writing this down as well. 0.25. Okay, because you'll write this down in your worksheet in a little bit. Let's do one more. Her 5th shot made it in. So now she has 2 hits out of 5 tries total. That's a 40% hit rate. So now the line has gone up to 40%. Okay. Now I'm going to speed it up a little bit. And instead of just doing 1 shot at a time, I'm going to have it do 5 shots at a time. So it'll do them one after the other, and it will give us 5 dots all at once here. Okay, here we go. Miss, hit, hit, miss, miss. And we extended our graph out 5. So we've gone 10 shots in at this point, or maybe 9 shots in. She says she has an 80% hit rate. She says 80% of the time she makes free throws. Looking at this data so far, decide for yourself, is this enough evidence to say that yes, she is an 80% free throw shooter, or no, she's not? In the beginning, so the fact that she missed one at the very beginning, that one shot that she missed doesn't necessarily mean she's not 80%, right? Like an 80% free throw shooter misses it 20% of the time. So maybe she just got one of those misses there in the beginning. But we're 10 in now, maybe 9 in, and we're gathering information that so far she's gotten 40% of her 10. No, we are 10 in. I don't know why the graph isn't going all the way to 10. Whatever. Okay, so let's do, she's still at 40%. I'm writing this down so you guys don't have to later. Do another 5. Now she's at a 33% hit rate overall. Do another 5. Miss, make, make. 35% now. Let's make it go a little bit faster. Let's do 10 shots at a time now. Miss, make, miss, 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 make, make, miss, miss, miss. Okay, she's at 33%. Let's do another 10. Okay, now she's at 40%. Do another 10. Okay, she's at 38%. Now she's at 38% again. Let's do 2 more groups of 10 here. She's at 40%. Do 1 more group of 10. So 38%. Okay, so looking at this graph, what we're seeing is that horizontal line up at 80 is what she said, but we're gathering evidence that kind of says something different. The first few shots, her missing them, that was not good evidence yet, right? Like that's entirely possible to happen to someone who's an 80% shooter. But we are really like zoning in on a certain percentage here. So what I want you to do is go to your worksheet now. I will do the same. And I'm going to fill in the table for you, and then I'll give you a chance to fill it in as well. Okay, so here I filled out the chart for you. So I want you to fill out the table, and I want you to sketch the graph that I have down below and really truly sketch it. I mean, I just plotted the points that we had on our chart. Notice that the actual graph is a little bit more wiggly than that, but I don't know exactly how the wiggles go. So I'm just kind of plotting the points I have in my chart there. So pause the video, fill out the chart or fill out the table like I have, copy down, sketch the chart, doesn't need to be perfect, and then answer number 2. If you had to make a guess as to what her true free throw percentage is, what do you think it is? And once you're done with that, unpause. Okay, so looking at this, it seems clear that her free throw percentage is not actually 80%, because 80% is up here, right? And she never even got close to it. In the beginning, the first few shots, there's enough fluctuation that you can't make many claims about the long term, but once you get enough shots, and you start to make some claims about the long term. And if we had to guess what the final percentage is, I mean, it's probably something around in here, right? Something like that. So if I go back to the applet and click show true probability, there it is. It looks like 35% is their actual true probability. And it started to kind of settle in on that fairly early. Okay, fairly early, but not at the beginning. That's worth saying. If you give it enough shots, it'll settle in on that. Okay, so 0.35 ended up being her true probability, and that's where the graph settled. So how could you make your guess more accurate? Well, oh, by the way, I should say this is the true proportion. Okay, so how could you make your guess more accurate? Well, we could see more shots. The more data you have, the better your average will be. So this is getting into an issue called the law of large numbers. And that is a basic idea in probability. That probability is about the long term. It's about when you know that something has a 50-50 chance of happening, it means in the long run, on average, you're going to get 50-50. It tells you nothing about the short run. It tells you nothing about small numbers. If you're flipping a coin and you have a 50-50 chance of getting a heads or a tail, that means in the long run, on average, heads comes up 50% of the time and tails comes up 50% of the time. It tells you nothing about what's going to happen on the next flip. You don't know what's going to happen on the next flip. Okay. And so let's practice doing some interpretation. We have another interpretation sentence stem to put in here. So let's use her actual probability, 35% of probability of making a free throw. To interpret that, we could say, if Mrs. Gallus takes many, so in the long run, many free throws about 35% of the time she'll make it in. She'll get a make. So interpreting a probability is all about the long run. It's all about in the long run, this is what will happen on average. Okay, so let's go down to the important ideas and fill that in. Really, it's just some basic ideas of probability, which for some of you is going to seem really easy because you've seen it before, and some of you haven't seen probability since middle school. So, or it's been many years. So it's kind of feeling like you're starting from scratch. Okay, it is a long run relative frequency. It is always between 0 and 1. 0 means something is impossible to happen, guaranteed not to happen. 1 is it's guaranteed to happen, 100% chance of it happening. In the short term, things are unpredictable. But in the long term, things are predictable. So this is kind of a theme that I'm going to keep coming back to. That probability is always about the long run, and you cannot use it to make conclusions about what's going to happen next. It's only about averages in the long run. Okay, and then the other thing we talked about was the law of large numbers, and let's write it down officially. Law of large numbers. If we do something many times, the proportion of desired outcomes will approach its probability. So probabilities only talk about when it happens many times. Okay, so write that down and then pause the video and go do the check your understanding and then unpause it and we'll go over it. Okay, so here's a check your understanding. So number 1 is practicing that interpretation. If Pedro drives to work many times, about 55% of the time he will hit a red light. Then moving on to some of the probability numbers. 0 means the outcome is impossible. 1 means it's certain. Very unlikely is close to 0, so 0.001. And then more often than not, that means it's some number bigger than 0.5, bigger than a 50-50 chance. So 0.6 or 0.99 work. And then the last one, so probability is unpredictable of short-term situations. The next baby, the probability doesn't say anything about that. It's still 50-50. It is unlikely to have a family of 7, I should say this, a family of 8 people, of 8 kids, where they are all girls overall. But as far as talking about the next child, we can't use probabilities to look at that next thing. Beyond the fact that this is terrible family planning plan. Anyway. Okay, so that's it. You are done with 5.1 day 1. Go rest, relax, and jumping down to the chapter 4 test, and we will get back to more probability on Monday.